I would like to introduce Moty Fania, the CTO of Advanced Analytics at Intel, and he will share with us today how to accelerate AI in the enterprise.
Wait, let me walk first and then okay. So good morning everyone, and yes, I'm going to talk about how to accelerate AI in the enterprise by enabling continuous delivery of AI. At least I'll share how we do it at Intel, and hopefully you'll find it interesting. So maybe a bit late in the AI week to talk about what AI, but let's just align about what we mean by saying AI. AI, from our perspective, is all about being able to replace human decision with an algorithm, okay? So obviously we're talking about not just automation, we're talking about decisions that require judgment or intelligence, and being able to do that with a machine is very powerful. Obviously, we don't have the ability to do it in a very broad spectrum. I mean, algorithms today are able to address a very specific domain. This is why we call it narrow AI or weak AI. But it is still very, very powerful because you can have many of these weak AI algorithms and address issues that are real. Just to give you context of what we do at Intel and how we apply AI for the internal usage, and this will give the context for the whole talk later on, let me tell you about my team. So the Advanced Analytics team at Intel actually works across Intel and applies AI across different domains, identifying the bottlenecks where we don't have enough humans to do a specific thing, and then scaling it with AI. For example, we don't have enough our validation engineers, so we can take some of the decisions that they have to take and replace them with AI. Nofar, which is the talk that is going to come after me, will obviously elaborate much more about each of the verticals, but the bottom line is verticals that are targeting specific domains at Intel and attempting to identify the big problems that exist there in order to transform or to achieve radical change in the way we do the business and achieve value. So I won't go through them because Nofar will, but I would like to talk about how to enable or accelerate the pace of AI. So obviously, as part of this work, we have deployed hundreds of models to production over the years. Actually, we are deploying hundreds of models every year. And the question is, what's the right way to deploy model? Because there's a lot of emphasis about the models. I mean, right, when you think about AI, we usually focus about the model and creating the model and training the model, but it's not enough. Once you have a model, there's a question of, okay, how do I realize the value of this model? How do I put it in production? And obviously, there are many ways to do that, right? I mean, it's not one way of doing that, but I want to share what we do. So one way to do it is to go, I have a model in my hand. I mean, I trained it. I invested a lot of effort to get it. And now I can try and build a custom application around it, meaning I build an application. It doesn't matter if it's Java or Python or any other language, where I deal with bringing the data into the model. I mean, getting the data, applying the model, doing some preparation of the data if needed, and exposing the results. And it's very easy. It can take me a week or two to build such application and maybe a few more days to test it. And it sounds good, right? I mean, you have a way to deploy models to production. However, this is not as good as it may sound because it's not a scalable approach. Over the time, you will find yourself with potentially hundreds of models scattered all around. Each one of them is doing their thing. It's not easy to deploy. I mean, investing 2 or 3 weeks to deploy a model is a lot. I mean, it's definitely not what we would like to have. It allows very little reuse because each time you invest, all the wrapper of the model is in many cases the same, but you still have to do it many times. There's no separation of concerns. I mean, in many cases, it means that the data scientist has to deal with engineering aspects or vice versa, which is not bad. And the worst thing, and I think this is the worst thing, that we know that models tend to degrade over time. They don't stay as they are. There's data drift, things change in the environment. And over time, you'll find that you have escalations and models that are breaking, and people are not happy. And in many cases, a model that breaks actually can create damage. It's not that just that it doesn't provide value. It will actually create damage to your operation. So this is not a good way to do it, and this is exactly why we go with a completely different approach, and this is the approach of enabling AI platforms. And these AI platforms are actually built in order to achieve few things, okay? So first, and this is one of the important things, is to enable continuous delivery of models. We want to be able to deploy models to production with a click of a button. I mean, a push of the code to trigger the deployment to production shouldn't be anything more than that. Obviously, models need data. So AI platforms need to take care of this. I mean, either bring the model to the data or the data to the model, doesn't matter, and prepare the data for the model. Sometimes it's trivial. In some cases, it's not. It could be a complex stream thing. It could be an activity that goes outside and does a lot of data collection. So bringing the data into the model on an ongoing basis is important. The third thing is, of course, to enable the value, to enable the closed feedback loop. I mean, you want your model to provide this prediction or prescription or do whatever the actuation that it has to do, so you have to have a closed feedback loop, and the AI platform has to take care of it, to have the hooks into the business domain where you could actually actuate or do whatever you need to do with the results of the model. And last, but definitely not least, is about sustainability of models or manageability aspect of models. I mean, as I said, it's not enough you're not done when you deploy the model to production. Actually, you've just begun, because models can then stay there for years, many years. And if you don't do anything, they are likely to break at some point of time. And if they break, it means that you have to spend effort and time and resources in order to fix them. And it can divert your attention from building new stuff into addressing old stuff. So putting in place in the AI platform all of the things that are required to sustain models in production, which includes collecting indicators of the model, of the health of the model, addressing needs for retrain, intelligent retrain, tweaking of parameters, many things that should be done, have to be done, and can be done automatically as part of the AI platform instead of doing it manually and by people. So the ability to deploy faster model and self-sustain it in production is the main goal of the AI platform. So I said a few things I mentioned here, but the thing here is that we want to enable the separation of concerns. I mean, ideally, the data scientist should focus on building the right model, and once the work there is done, it should be no matter of pushing the code, which is the model is code at the end of the day, and getting it into the production environment. So we want to be, with the AI platform, we know that we can easily deploy it, and we know that we have in place all of the things that are required in order to get the model running in production. It includes all of the aspects that are written here, and I mentioned most of them already. So let me show you some examples, real examples of AI platforms that we have developed internally and explain what are the main characteristics. So as I said, we make sure that all of our AI platforms are actually built with the ability to integrate into the business domain. So this is why we don't have one AI platform for everything. As you saw, we have 6 verticals. Each vertical has its own unique needs, its own unique data, its own unique characteristics, and we want to have the integration into the business process. So even though we started almost 10 years ago with one general purpose AI platform that was supposed to serve all domains, we got to the conclusion where it makes more sense to be specialized for each domain and to have the ability to deal effectively with the data from one hand, to run the models, of course, but also to expose the results into that specific business domain. So continuous delivery, I already mentioned it, the ability to deploy model, and I will show in a minute how it looks. And our platforms are actually built for CI or CD, to be more accurate. I mean, we are not investing in UI for doing stuff. No, we want this to be code-based, because when it's code-based, you can actually use the same best practices that you have for software engineering. I mean, there's no reason to reinvent the wheel. You can apply the same practices of software engineering in the world of AI. So you have code, you push the code, it goes through all the testing that are required, and including the model, of course, and is ready for either as a release candidate or actually deployed to production if it's a continuous deployment thing. So let me just scan very briefly through the platforms, and I then will go and show a concrete example with a bit more details. And Ofa will show actually another example, I believe. So the domains that we deal with. Product development is about dealing with the units once they are manufactured. There are hundreds of decisions that has to be made of how to, for each unit, in this process, which tests to run, how to pack it, different consideration of how to fuse it, and so on. This decision could have been made by a human, theoretically, maybe, not likely. In most cases, a human won't be able to make decisions per unit in the volume that Intel manufactures. So this is a great way where we can have a dedicated platform that actually, in production, as the unit flows into the test route, can make the decision. Think of it, the unit go through a route of testing and decisions, and our algorithms are being deployed to this platform and affect the way the unit is being tested and routed. So this is obviously a very specific platform, but the fact that it's specific allows a lot of power because it's highly embedded into our assembly test manufacturing activities. Hardware validation, this is something that Nofar is going to give as an example. Again, how to enable pre-silicon validation at scale when you don't have enough people to do it manually. Sales AI, again, sales is another example where you have a human bottleneck there. You will never have enough salespeople, to cover hundreds of thousands of accounts. You won't have. And since you won't have it, the best way to address it is by having a system that can do some of it autonomously and at least help the people that you do have to do their work in a much more efficient and optimized way. Manufacturing is another good example for a place where you have a platform that is able to collect data from sensors, time series mostly, but not limited to, and close the loop in different places. It could be very close to the edge, it could be in the cloud, it could be in the fog environment in the middle. So you have here a platform that is specialized in dealing with time series and is very portable in where you can deploy it. And we have another one that is related to Mobileye and the ability to leverage the data that the cars collect. So again, I won't be able to get to the details of each platform, but I picked Sales AI as an example where I want to give you a bit more information about that platform and what we do there. So, okay, so let's look how the continuous delivery process could look like. So again, this slide should be very familiar to anyone who is doing software development because we don't want to reinvent the wheel. So what we want to get to, the target here is a situation where the data scientist pushes the model by complying to a few standards, of course. I mean, we do dictate some standards of how the model should be exported and what tests should be associated with that model and the indicators associated with this model. But once this is ready, this is just a matter of pushing the code into the source control, and then it triggers the job. Your CI job can do what it has to do in taking this code, building the necessary containers if relevant, if you are using a container environment, and running all of the tests that are associated with the system and the model, and then deploying it as a release candidate or actually deploying it into the AI platform for production. So it could be a fully automated, 100% automated process from the beginning till the end. Usually we don't do that. Usually we don't go directly to production. Usually we stop at a release candidate, we apply some more judgment and some more testing, and only then we deploy to production. But it's a matter of a push of a button. And this is what's important. It's we are not talking about weeks of development of an application and so on. It's a matter of just deploying into the platform. And this is very, very powerful because it allows you now to know that the model has a place where it can live, and you know that it will be effective in production immediately. Okay, so let's take the Sales AI platform as an example. And so hopefully I will be able to show you how it looks like in that example. So in the sales AI context, we are talking about being able to replace what the human does. I mean, we don't have enough sales people. We want to have a system that does what they do. And what they do is usually to understand the world. I mean, they sense their account that they're covering. They understand what's going on in the world. And based on that, they interact with the customer, right? They apply some reasoning. They understand what is the right thing to offer, what is the right thing to do, trigger a call, trigger an offer. And based on that, they do that. And of course, learn from their mistakes if there are any mistakes that they are doing. So we want to have the same thing using AI. And the platform that we have built here I think, is something that will give you an understanding of how important are some of the characteristics that I mentioned before, because it's not always trivial to do the 4 things that I mentioned at the beginning. I mentioned at the beginning the need to bring the data into the model, right? So sometimes it's not trivial. For example, in our Sales AI platform, we have to crawl millions of web pages. We collect data from tweets, news. So in addition to the internal data, we are doing a lot of external activities of bringing additional data about our accounts. We want to understand, to sense the world. So this means that there's an ongoing process. It's an always-on system that is continuously bringing data from the outside world and processing it. And obviously, the right way to do that today is a message bus where the data flows in, and you have producers and consumer with a microservice architecture that allows us to build and extend the platform as needed when we have to need more capabilities. So again, it's not always trivial to bring the data to the models, but in this case, once you do it once in a platform, all of your models can benefit from the data that was brought into the system. I mean, you have it in their message bus, so you can now have your models operating on that data. Microservice architecture gives us the agility to be able to add and modify existing services. I think this is the way to do stuff today. Hopefully everybody understands it. We usually base it on Kubernetes and Docker containers and microservices that each one of them has a very specific task. They don't know about each other, the microservices. They just get the data from the message bus and give the results back to the message bus. Someone else, another microservice could use the output of one microservice as its input, but they don't know about each other. So you don't have a monolithic spaghetti kind of platform where you can't change anything because you're afraid that it will break. In many cases, storing the data by itself is not trivial. In our case, for the sales, obviously we need the ability to deal with text. So we have to be able to search. We are talking about big data, so we need big data storage. We need the ability to store also our SQL kind of data. But in this world, we found that we also have a real need to store the data as a knowledge graph, because we are talking about interconnected entities. You can know a lot about a product and a lot about a specific customer and a lot about a specific person, but it makes it so much powerful when you know the relationship between them. You know now that this is the company that sells this product, and this person works for that company, and this company acquired that company or partners with that company. So when you have a graph and the ability to map the world in a knowledge graph, you get much more ability to do the reasoning out of this data. So in this case, again, we've invested in this platform with the ability to build and maintain graph on an ongoing basis. It's not a one-time thing. You need to continuously bring the data and put it into the graph, refresh it from time to time, and this takes effort, but this platform has a service in it that knows to do that. So we don't have to care about it anymore. It is being done as part of the platform. Obviously, when we're talking about crawling web pages and tweets and news, you have to apply a lot of natural language understanding. I mean, for a human, you read an article, you understand it, but for a machine, you have to obviously teach or train the system to be able to deal with this data and understand it. And it involves many models, okay? It doesn't sound like, it may sound one sentence. You may need to apply 3 or 4 models just to understand the different thing. What are the entities there? What are the relationships between them? What is the intention in this sentence, and so on. So the challenge here, obviously NLP, NLU is something that exists. We didn't invent it, but the challenge here is more about how to train these models when you don't have any labeled data, right? I mean, we don't get the data with the labeling in it. So the ability to train our models in a weak supervision environment was a challenge. And what we have done is to introduce into this platform a capability that is based on an open source called Snorkel from Stanford. I don't know if you heard about it, but Snorkel allows or helps training models in conditions of weak supervision, where you don't have enough labels. So you start by defining some high-level rules, and then this takes it further into something where you can actually train your models without a lot of labeling. And this is very significant. And again, this is something that is embedded into the platform, so it's being taken care of as part of the platform. And last but not least, this platform has to make decisions, hundreds and thousands of them every day. Right? I mean, this was the whole point. I mean, taking the models, applying them, and then letting the system deciding what to do. And we are, by the way, the decisions at the end of this funnel, we are doing one of 2 things. We either, as I said, we call it assists. I mean, like in sport, okay? We provide account salespeople specific, we identify specific conditions that can trigger a conversation with the customer or trigger something. I mean, we know that this customer is now entered a new domain that he didn't do. So now you can do something with it. Or we know that one company acquired another company. Or this could be by itself something that is meaningful. And there are many, many conditions where like that, okay? So identifying the events based on all of the processing that we do that can trigger an event and give a recommendation, a very specific recommendation to a salesperson. Beyond that, we want also to do, I mean, as I said at the beginning, we don't have enough salespeople. So it means that for most of the long tail of almost 100,000 customers, we want to be able to cover them without people because there's no one to do it. And we can apply AI and actually, based on the processing that I mentioned already, to offer them very specific tailor-made offerings automatically. I mean, the system does it autonomously interacting with the customers. So for this purpose, we have deployed, again, we are talking about many deep learning algorithms. So one of the services that we have deployed here is a service for deep learning inference at scale, which means to do that at scale in a very efficient way. So it's a system that takes care about batching for the inference purpose, smart batching using in-memory cache, the ability to do it asynchronously, so you can leverage your hardware and maximize the throughput of your inferencing hardware, and many other things that are related to deep learning inference. Again, I don't have time in this talk to elaborate on it. You can maybe find it in the web because I already presented it, but very smart system that knows to do it in an asynchronous way at scale and to allow you to run many deep learning models very efficiently at scale, and this is part of the system. So once we have to deploy deep learning, we know a model, we know where to put it and where to deploy it. And by the way, the serving mechanism in this case was TensorFlow serving. I guess you are familiar, not TensorFlow. TensorFlow serving, it's a different technology that basically allows us to deploy models. And again, it's not a one-time thing. You sometimes need to deploy another model or to update a model. You need to maintain versioning of models and many, many other aspects of manageability that are given by this platform. And of course, also serving it in a very efficient way using the capability that I mentioned called Archelon. So this is one of the subsystems that we have. And again, if looking on the whole picture, this is how in high level a platform like this looks in the sales AI context. We are talking about many, many sources that are being continuously fed into a message bus. different kinds of services and microservices operating on top of this data, where you have, again, as I said, you have places where the models are being hooked into and deployed into things like Archelon and other stuff, and the data is being processed as required, including graph and all the things that I mentioned, and then it goes to the interaction mode, where you want the result of these models to interact with the world in different APIs and different things, as I mentioned before, okay? So this is in high level, and again, the databases, as I said, it's one logical unit, but it can be made of many technologies because there isn't one technology to rule them all. So this is it. Hopefully I covered, and if there are any questions, I'll be happy to get now. Yes. Yeah. Actually, we measure it very strictly, and we involve finance people in that to measure it in a way that is tangible and hard value, and we invest a lot of it. And the value is significant. It's hundreds of millions of dollars in the past few years measured. Yeah, sorry. Again, we deploy hundreds every year, so it should be thousands, I believe, but I don't know the exact number. Any more? Okay, thank you very much.